Assalamu alaikum. So today the topic of our discussion is the disease of thyroid gland. Okay. So in this lecture, first I will try to explain how thyroid hormone is formed. Okay, so that we can easily understand which disease has which defect of metabolism. So first of all, try to this is the topic in which we just try to get a little knowledge how iodine is used and how thyroid hormones are formed with the help of iodine in some proteins. Okay, so first of all, this is a follicular cell. This is a follicular cell in the thyroid gland. Okay, this follicular cell has two sides. Okay, this is the basolateral side, this is the luminal side. Okay, so iodine is first entrapped with the help of sodium iodide symporter. This is the sodium iodide symporter, you can say sodium iodide channel. Okay, iodide enter into the follicular cell, this is, and then it is released as soon it is entered into the cell. Okay, and when iodide ions exit from other side, this iodide ion is converted into iodine. So there is an oxidation process, and their enzyme is called thyroperoxidase. Okay, and this is the enzyme which is activated by the TSH, thyroid stimulating hormone. Okay, okay, so then skip this thing and come to this point. This is a protein which is present in the thyroid cell, follicular cell. Okay, this is called thyroglobulin. You know that proteins are form of amino acids. Okay, different amino acids are combined with the peptide linkage. Okay, and one of these amino acid is called tyrosine. One of this is called tyrosine. Okay, so this whole protein is a thyroglobulin, and this thyroglobulin contain an amino acid which is called tyrosine. Okay, why I am telling you? Because the tyrosine is the amino acid of thyroglobulin on which iodine will be attached. Okay, so the first reaction was the oxidation. In the second reaction, this iodine is added to thyroglobulin with the help of again same enzyme thyroperoxidase, and this reaction gives us this molecule in which thyroglobulin amino acid tyrosine is now iodinated. It means tyrosine is attached with iodine. Okay, so we when one iodine atom is attached with tyrosine, we say it monoiodo, mean one iodine attached to tyrosine, monoiodo tyrosine. When two iodine attached, it will call diiodotyrosine. So like this, monoiodotyrosine and diiodotyrosine molecule will be formed according to how many iodine are attached to the tyrosine amino acid of thyroglobulin protein. Okay, so in the next step, there is a coupling. There is a phenomena which is, this phenomena was iodination. This then next one is coupling. It means when monoiodotyrosine and diiodotyrosine combine, so 2 and 1 give rise to T3. It means when monoiodo and diiodotyrosine combine, add up, this will give triiodotyrosine. Okay, and triiodotyrosine is called T3. Okay, T3 is triiodotyrosine. But when diiodotyrosine is combined with diiodotyrosine, the same instead of monoiodo, so it when diiodotyrosine and diiodotyrosine combine, it will give us the tetraiodotyrosine, which is called T4. So T4 is tetraiodotyrosine. So some of the these compound are coupled and give T3 and T4, and some are remain uncoupled. Okay, so in the next step, this uh, molecular structure is reabsorbed by this absorbed by this follicular cell will have, we say, pinocytosis. So this phenomena pinocytosis occur here, and this is absorbed into the cell. Okay, like a bubble. So this compound when absorbed, it undergo a process which is called proteolysis, proteolysis. In proteolysis, pro proteolysis This process is called proteolysis. Okay, in proteolysis, what happened? T3 and T4 are released from this thyroglobulin, and these, when released, then come out to the cell and release into the circulation. So it release into the blood vessel. Okay, T4. But what happened to other things? This monoiodotyrosine and diiodotyrosine, these are released as iodine. So this iodine of diiodotyrosine and monoiodotyrosine are released and can be reused. Okay, and the thing which is this thyroglobulin protein, thyroglobulin, this is reused here. Okay, so this is the whole process of synthesis. So this process is under the supervision of hormone which is called TSH, thyroid stimulating hormone, help in the formation of thyroid hormones. Okay, so now come to the diseases. This was important if we want to learn how these diseases and what is the pathophysiology of these diseases. Okay, so first disease in which the hypothyroidism. What is hypothyroidism? Hypothyroidism, it means there is a decreased T3 and T4, mean thyroid hormones are decreased. So when this thyroid hormone will decrease, okay, it will call hypothyroidism. Okay, and in hypothyroidism, the pathophysiological causes may be the iodine deficiency. It means a person is taking a small amount of iodine. If the iodine is small amount, this iodine will not be present, and so these all process will not occur, and so there will be no formation of T3 and T4, and hypothyroidism will occur. The second most common defect is defect in the hypothalamo-hypophyseal tract. What is hypothalamo-hypophyseal tract? Look, we have hypothalamus here. Okay, below the hypothalamus we have pituitary gland. I just write P. Okay, and hypothalamo-hypophyseal tract give thyroid releasing hormone. Thyroid releasing hormone. Then this pituitary gives thyroid stimulating hormone from the interior pituitary gland. Pituitary gland has two parts. I will tell you in more detail in the hypothalamo-hypophyseal tract lecture. Okay, so in this hypothalamus will release the thyroid releasing hormone. This pituitary gland, under the supervision of thyroid releasing hormone, release thyroid stimulating hormone, which act on the thyroid gland. Very good, thyroid gland. I just write THY. This is thyroid gland. So this THY then gives rise to T3 and T4. Okay, so if there is a defect in thyroid, this hypophysis means pituitary gland. Okay, in this tract, so it means if there is no production of TRH or TSH, there will be no production of T3 and T4. Okay, this is called the defect in hypothalamo-hypophyseal tract. The second most common cause is that sometimes what happens that autoimmune response occur. Okay, in which autoantibodies are formed, and these autoantibodies which are formed cause the destruction of the gland, and when there is a destruction of gland, there will be no the follicular cell. When there will be no follicular cell, no process will occur. Okay, and in which T3 and T4 will be decreased. So this was the pathophysiology, and now sign and symptoms of disease. Cold intolerance. Why? Because normally the thyroid hormone increase the metabolic rate. When thyroid hormone decrease, the metabolic rate will be decreased. When the metabolic rate decrease, it means less heat production, because metabolic rate is directly proportional to heat production. Okay, so less heat production, the person temperature will be decreased, and it becomes the cold intolerance. Okay, and increase weight. Why? Because when a person metabolic rate is decreased, if a person does not doing anything, its weight will be increased. Okay, and short stature, this occur in the in the newborn. Okay, when the newborn in the newborn has deficiency of thyroid hormone, this will happen that his growth will be retarded, and it will lead to cretinism. Okay, and then we have goiter. What is goiter? This is this point goiter should need to explain then what is goiter and why it's happened. Goiter, it means the swelling of thyroid gland. Okay, so when this swelling occur and why? Okay, let's go to this point. This thyroglobulin, okay, this thyroglobulin come out the cell, and in the colloid, this is the colloid where the reaction occur, okay, attach with the iodine and form the T3 and T4, all these things, okay. And under the supervision of thyroid stimulating hormone, okay. But when a person has the deficiency of thyroid stimulating hormone, okay, his cell, and there will be no production of T3 and T4, okay. And his the person's cell, follicular cell, thinks that the thyroid hormone are decreased as there is a decreased thyroglobulin, but this is the not reality. This is the only thinking of follicular cell. They think that the T3 and T4 are reduced because thyroglobulin is reduced. They think wrong, and so this wrong thinking give them message that this thyroglobulin should be increased, so that T3 and T4 should increase, okay. But this will not help out. It will only lead to increased amount of thyroglobulin. When there is increased amount of thyroglobulin, it will lead to swelling of the thyroid gland, which is called goiter, okay. And all other thing I explain, okay. So hypothyroidism, most famous disease, Hashimoto disease. What is Hashimoto disease? In this disease, there is a thyroid immunoglobulin, okay, anti-thyroid thyroglobulin, sorry, anti-thyroid thyroglobulins are produced, which are the autoimmune response in which the anti-thyroid thyroglobulin are produced. These anti-thyroid thyroglobulins, these are the antibodies which destroy the thyroid gland and which will lead to hypothyroidism in the Hashimoto's disease, okay. Then we have goiter. I explain each and every part of goiter, okay. In goiter, the follicular cells wrongly imagine that the T3 and T4 are decreased because TG is decreased, and this wrong thinking of follicular cell will increase the amount of TG protein. When TG is increased, it causes swelling of the gland, and which is called goiter, okay. So the second one disease is the hyperthyroidism. What is hyperthyroidism? It means increase amount of T3 and T4. Increase amount of T3 and T4. Why there is increased amount of T3 and T4? The first and famous is over ingestion of iodine. When a person is taking very large amount of iodine, T3 and T4 production will be increased. And the second one is the tumor. When a person has a tumor of the follicular cell, so tumor cell is the cell which has a rapid function, okay, which tumor is a rapid division of the cell. It means a large amount of follicular cell will be present, and if there is a large amount of follicular cell, that will lead to large amount of T3 and T4 hormone production. But these hormones are somehow non-functioning, but this tumor still lead to hyperthyroidism, okay. Then we have the TSI, which is thyroid stimulating immunoglobulin, okay, production. This is the immune response in which this thyroid stimulating immunoglobulins are produced. So this thyroid immunoglobulin, this is related to TSH. TSH and TSI have the same role. These TSI attached here on the sodium iodide importer and on the side which are acted by a thyroid stimulating hormone, can be activated by thyroid stimulating immunoglobulin. In the simple word, I can say that TSI act on the receptor of TSH, okay, and has the same functioning as TSH. So when a person body has TSI, its TSI will give the message like TSH and increase the production of thyroid hormones. But there is a difference between the TSH and TSI. The TSH has a negative feedback mechanism. What does it mean? That when thyroid hormones are increased, this will negatively decrease the level of thyroid stimulating hormone. So when the thyroid stimulating hormone decrease, these T3 and T4 level which were increased now decreased, okay. So it has negative feedback mechanism, but TSI has no negative feedback mechanism, which gives this ability to remain attached on the receptor and continuously form the T3 and T4 with no negative feedback mechanism. So no TSI level will decrease, only it remain the same and increase the production of T3 and T4 will lead to hypothyroidism, okay. This TSI production occur in the Graves disease. Okay, so the phenomena which I just explained was the Graves disease. Okay, now come to the sign and symptom, and these sign and symptoms just opposite to these. If you want to have the knowledge, you can easily understand why there is heat sensitive person, because the person has high basal metabolic rate, because we know the thyroid hormone is normally related to metabolic system. When it increase, the basal metabolic rate will be increased, and when there is increased level of metabolism, there will be increased production of heat and person become heat sensitive. And the person when has high level of basal metabolic rate, so this person has tumors in his hand which are specialized thyroid tumors. Okay, and persons have Graves disease which I explained now, and the person weight is decreased because of high level of metabolism in which the energy is high amount of energy used, so his body all content is used, and person weight decrease because the fatty acid, glucose, these all are used in the basal metabolic rate increasement, and the weight of the person will decrease. Okay, so this was the thyroid gland, its disorder, and all the things which are related to this. If you like the video, please like and subscribe my channel. Thank you. See you. So